Started recording. So I just wanted to discuss the couple of questions on the probability, right, which we left halfway dangling last time. So the one was on the stick problem. So just to recap, you have a meter-long stick, and then you cut it at 2 points. I thought about a better explanation. I was fumbling with it yesterday, right? So this is, you have a meter-long rod, and then the problem is you just cut it at randomly some 2 points. Okay, what is the probability that the 3 parts will make a triangle? Recording, right? Yeah. Okay, cool. Right. So so the two endpoints are A and B, let's say. Okay, so this is P and Q. So one thing is obvious, that P and Q must be on opposite sides of midpoint. Opposite sides of what, let's say this is the midpoint, right? Let's say the midpoint is M. 50 centimeter mark. Okay, opposite sides of M. So that's obvious, because if P and Q fell on one side, then the remaining portion will be bigger than half, right? So that's obvious. So P and Q must be on opposite sides of M. Okay, so let's measure. So exactly same as what I told you. There's just one mistake I made. So let's say we measure the length of P from here, and let's say we measure length of Q from here. So we are saying either P should be less than half and Q should be less than half, right? Which ensures that they are on opposite sides of M, or it should be the other way, where both are. So this is, okay, I'll draw it here. So this is A, this is B, and let's say both P and Q are more than half. Let's say P ends up being here, okay, and then Q ends up being here. Okay, then also we are, I mean, that's a minimum condition, right? That does not assure us anything. I'll just put it somewhere here, maybe. Okay. Okay, that's a minimum condition, that they should be on opposite sides of the midpoint. So again, my P will be measured from here to here. So my P is still from here to here. And my Q is still from here to here. So we want P should be greater than half and Q should be greater than half. Okay, so either both should be less than half or both should be greater than half. Okay, so let's assume, so in the second case, so P minus half. Okay, so that quantity, so that is which quantity? P minus half is this quantity. Okay, so this quantity is P minus half, right? So let's call that some letter, right? Let's say, what shall I call it? I'm struggling for letters here. R, fine. Okay, and then this Q minus half, let me call that as S. Okay, so this is Q minus half, which is S. Right? So we want this quantity R plus S in such a case. In this case, we want R plus S to be less than half, right? R plus S is the middle portion, right? If I still divide it, I make 2 cuts. The 2 cuts happen to be at P and Q. So obviously, the first part is from A to wherever the first cut falls. In this case, Q is where the first cut falls. And then the other cut is from B, that end to wherever the second cut was. And then the middle portion is the middle portion, right? So in this case, the middle portion is threatening to be the largest. So we want that to be less than half. Okay. And then this portion is P less than half, Q less than half. If that's the case, then we want, so we want P plus Q to be more than half, right? So these are the 2 restrictions that we have, right? So now how do we graph this collectively? Again, there might be a simpler way, but I thought this was more intuitive for me, at least. I don't know, where did I lose this now? Oh gosh. Okay, there it is. Okay, I'll just do it. If I create one more page, I don't know why it goes here up. Okay. Okay, so if I have to plot both of them together, so I can just put x-axis, y-axis. Okay, so left alone, let's say this is P. P can be anywhere from 0 to 1. Left alone, Q can be anywhere between 0 to 1. So the entire sample space is this full square from 0, 0 to 1, 1, this entire sample space. Now in this, we can divide into two parts, right? So let's divide halfway. So this is halfway here. So this is half vertical and half horizontal. Okay, now, so the case that we discussed yesterday was this bottom left, right? If P is less than half and Q is less than half, right? So in this zone, we want P plus Q should be greater than half. So P plus Q equal to half will be, so this is the P plus Q equal to half. This is 1, remember, this is 1, this is half. This is half and this is 1. So P plus Q equal to half will be this line from here to here. P plus Q equal to half will be this line. Okay, and so if we are in the bottom left quadrant where P and Q are both less than half, then we want the sum to be greater than half, which means the favorable region is this. Right, so this is the favorable region. On the other hand, if P and Q are both greater than half, which means in the top right wala quadrant, so clearly this quadrant will not work and this quadrant will also not work. This is the case where P and Q end up on the same side of the midpoint, in which case clearly the triangle won't form. Right, so if P and Q are on the opposite side by each being more than half, then we want the excess P. So P minus half is my R. The excess is this, right? So on top of half, the extra R, on top of half, the extra S, which means in a way, R and S are like as if this is the origin for R and S. So R is from 0 to half, S is from 0 to half, right? You can think of P, you can just shift the origin by half comma half. So the extra R and the extra S that we get, that R plus S must be less than half. So R plus S equal to half will be this line. R plus A equal to half will be this line. So we want that extra R and the extra S that we have should be less than half, which means this is the favorable region. Right? And now we can see that the total shaded area is 1/4 of the entire picture, right? And therefore the probability is 1/4. Does this make sense, guys? Arnav, are you with me completely? Did this make sense to you? Arnav, are you guys able to hear me? Dipra, are you able to hear me, right? Yeah. Understood, right? Yeah. Arnav is giving a blank look. Arnav, your audio is okay. Arnav Doltani. There's only one Arnav in class anyway, right? So, okay, fine. Maybe he'll figure it out later. All of you good? Anika, Sumer, understood this fully?
Yes.
Okay. Any other way you guys want to share, or did you guys think about something? Moksha, did you think of something else in this problem?
Not really, sir.
Okay, but makes sense, right? Okay, and for both questions are important. One where each is an independent piece, which we did yesterday, where the answer was half, and the other one is this. Okay, the other question I'd given you guys to ponder on was this. There was a circle. I said, if you have a circle, what is the probability? If I randomly pick 2 points on the, if I randomly pick 2 points on the 3 points on the periphery of a circle, what is the probability that will enclose the center of the circle? So not sure if you guys thought about this question, if you remember this. So I randomly pick 3 points on the circumference of the circle. So I'll give an example. Control 6. So this is first point, this is second point, and this is third point. So I connect all 3 of them. So this case, it just happens to enclose the center of the circle, which is here. Actually, it's well within the, right? So this is an example where it encloses, and you can draw another example where it does not enclose. Okay, so this question is clear, right? What is the probability that the triangle encloses the center of this circle? Did you guys think about this question? You remember I had given it at the beginning. Not sure if anyone has an answer on this or a method.
I don't have an answer, but I think of a method.
Okay. Go ahead, please.
So
Can you share?
We could consider 2 possibilities that all 3 points are either on the right side of the circle or on the left side of the circle. if that is the case, then it will not enclose the circle. Otherwise, it will enclose the center, I think.
Okay, all 3 points are on the right side. Okay, so first of all, so basically you want to start by saying, without loss of generality, I can assume the first point is at the somewhere, let's say at the bottom of this circle, right? So I can always, wherever the first point I choose, I can always twist the circle and such that the first point comes directly below this. Let's say this is A. Now you're saying, yeah, correct. Now you're saying B and C must both be on the right side of the circle,
Either right or left.
either
Both
right
should be on the same side.
or the left, for the triangle to form, for the
Yes.
triangle to enclose or not enclose.
Not enclose.
To not enclose. Okay, so let's say, and then the reverse is whenever it encloses it.
Yeah, I guess so.
Okay, so okay, let's say I put B here. Okay, let's say I put B here. Okay, and now if I put C here, B is on the right side and C is on the left side, but it still does not enclose, no? So you can see, right, ABC is like, right? ABC is here. You can see it does not enclose.
So I think I just meant like it should be on one side of the radius, like either all above or below, or all on the right.
Yeah.
Or
So
all.
how do you formalize
The
that? Yes,
answer
correct.
5 by 8.
Sorry, what is that? Ritisha,
The
what did you say?
answer 5 by 8.
5 by 8.
Yeah.
So I thought 2 by 8.
So
2 by
the
8, which
method
is
that Sid used, maybe you can modify it a bit by dividing it into 4 quadrants. Maybe that would be more effective.
Yeah.
okay. Okay, Moksha, I heard your answer, heard what you said. I heard 5 by 8 and 2 by 8. Okay, any other answers? I think it's, I remember it's either 1 by 2 or 1 by 3 or 1 by 4. I don't think it's 5 by 8. I think it's 1 by 4. Let's do it together. I remember it being 1 by something. So it's one of these only for sure. So Sumair, you got 2 by 8, which is 1 by 4, right? Or was it someone else? Sumair, you got 1 by?
Yeah, so basically I just divided into, so I actually did like some visualization. I didn't really do it like.
That's fine. Even intuitive answer is fine. Yeah, go ahead, Sumair.
Yeah, like,
Okay.
so I divided this, wait, sir, I don't know how to explain how I divided it. Is it possible to annotate?
Yeah, please do. Yeah.
So I did something like, wait, give me a second. So I don't know how to draw a line. Yeah, okay.
Or if you dictate, I can follow your instruction. Okay, all right.
Yeah, so I did something like this. Wait. Okay, I'm forgetting what my logic was. I did this yesterday only. I didn't do this today. But like, wait, I need to annotate again. If there are, so I think it's very similar to like, what's the probability of it being an acute?
Yeah, true.
I mean,
correct.
obtuse,
Obtuse
right?
or acute. Yeah, correct.
Obtuse.
Both are connected problems. Yes.
Yeah. So wait, if I just take this, if I take this as one side, this is one side. I remember exactly what I had done. I'm forgetting now.
That's fine. No problem.
Yeah.
Can you remove your annotation, because I don't think I can.
Yeah, sure.
Okay. Dipra, do you remember what you did for 5 by 8? Or was it Ritisha?
that
for
was
5 by
me,
5 by,
Ritisha.
yeah, Ritisha, what did you do to get 5 by 8?
We take like any point A below, then
Okay.
a circle won't be formed if both are below the center. So the probability of that is 1 by 4.
Both are below the center, which means you mean
B and C are both
Okay,
below
so-
the center.
okay. So if something like this, then you won't form a circle.
Yeah, that is 1 by 4.
Okay, but are you saying if B and C are both above the center, then the circle will be formed?
No, and then I add probability.
Okay. So further condition. So bare minimum B and C have to be below the center is what you're saying.
Yeah,
correct?
then it won't be satisfied.
But not necessarily, no? Let's say B is here. So you're forcing B and C to be below the center.
No, I'm forcing them to be above the center.
So you're forcing them to be above the center, right?
What I'm saying is if that both of them are below the center, then it won't be a triangle.
Okay, yes, I agree. If both of them are below, correct. Okay,
Yeah.
maybe I read too much. If both of them are below, you won't form a triangle,
Yeah.
and you're not saying anything else.
Then the second thing is if both are above but they're on the right side, so probability of that is 1 by 16. That then also circle won't be, like a triangle won't be formed.
Mhm.
And if both are on the left side, so the probability of that is 1 by 16. So 1 by 16 plus 1 by 16 plus 1 by 4 is probability of not forming.
Okay. And then you're saying if both of them are above and they have to be on the
Right
Say-
or left side.
both have to be on the right side. So for it to not you're talking
Yeah.
about for it to not enclose the
Yeah,
circle.
yeah.
Okay. So for it to not enclose, either both have to be below the horizontal line. So that's 1 by 1 by 4. Okay. So
How do
so
you know
you're
it's 1 by 4 if both of them are under the horizontal line?
basically she's saying both B and C can be anywhere in this 2 pi, right? She's forcing them to be in the top semicircle. So half into half. B and C have complete freedom. You've chosen A, you've realigned your circle so that A is the bottom. Now comes B. B can sit anywhere in the 2 pi, and she's forcing it to be above the semicircle line. So half, right? So now, okay, Ritisha, just to be clear, so you're saying probability for not enclosing center, correct? Not
Yeah,
enclosing center.
yeah.
Okay, so you want it to be probability of not enclosing center is 1/4.
Plus
Plus?
1 by 16 plus 1 by 16.
Okay, explain to me this 1 by 16 and 1 by 16 again, please.
If 1 by 16 is both are above and both are on the right side of the center.
Okay, so both are on the right side of the center,
Yeah,
or both are on this quadrant.
yeah.
Then also, it's not formed. Okay.
Yeah.
Okay. Anyone see any issue with this? 1/4 plus 1/16 plus 1. Okay, so this adds up to how much? Okay, Moksha, see an issue with this?
No, I don't have an issue with this. I have an alternate.
So okay, this adds up to 5/8, is it?
No, this adds up to 3 by 8.
3 by 8. Okay, 1 by 4 plus 1 by 8 is 3 by 8. And therefore, you're saying the probability is a reverse of this, which is
1 by
this is the probability of not enclosing the center. Okay, I'm clearly you're making a mistake. I'm not able to say what that mistake is. Just 1 second. So if one is above and one is below. Oh, okay. What about the possibility that one is below and one is above? Those possibilities, how will you consider? In those cases also, for example, let's say B is here and C is here. It's not getting counted in any of your possibilities.
Oh, yeah,
right?
yeah. Then it's
Correct?
wrong.
Okay, so that's enough to prove it's wrong, right? That's all I want to do.
So
okay?
I think I've got a good method.
Moksha, go ahead.
We'll start with A being on the
So
bottom.
first of all, what did you get? Did you get Sumair got 1/4? Did you also get 1/4?
No, I just found out this method. I haven't actually.
Okay. All right. Go ahead, please.
Okay, we start with A being on the bottom.
A being on the bottom. Yeah.
So firstly, if B and C are on the same side, like right or left, we know for a fact that it will be it will not flow the center.
If B and C,
Let me
say that
try.
again.
If B and C are on the same side of the circle, like right or
Yeah.
left, that means it won't be close to center. That's confirmed.
Correct.
So the chance of them not being on the same side is what's called 1/2.
This is similar
Right?
to what
said yeah.
Yeah.
Okay, now let's assume the first point B
Mhm.
moves a distance of x units along the right side arc. Let's say B is on the right side, okay?
Okay, let's say B is here, okay?
B moves x units along the arc. The arc length AB is x.
AB is x, so this length is x.
And let's assume what's called the circumference of the circle is 2 for simplicity's sake.
Circumference of the circle is 2. Now let's assume it's a unit circle, no? So 2 pi is the circumference.
No,
Okay,
but like it's just easier with 2. It doesn't matter that much.
It doesn't matter. It'll just confuse. That's why. So do you mind keeping it 2 pi, please? Let's keep the radius as 1. So 2 pi is the circumference. Okay. And now this distance is x. Okay, carry on.
So the distance, if AB is x, that means the arc length, the minor arc length AC, has to lie within 2 pi and 2 pi minus x.
Between 2 pi and 2 pi minus x.
Exactly. If 2 pi minus x is the arc length, it will just barely, like CB will be a diameter. if it's greater than 2 pi minus x, it will enclose the center. If it is less,
Uh,
it won't enclose the center.
Okay, so let me draw the perpendicular, let me draw the diagonal opposite point. So this is my C. Okay, now what are you saying? And
Arc
should I
length AC.
should I draw from A also to the other opposite?
Yeah, sure, if you want.
Okay. No, do you need it? You tell me.
Not particularly.
Okay, all right. Then I won't draw it. Okay, so C is here. Now what?
Sorry. Arc length AC has to be pi minus x. Right?
AC. Okay, AC is pi based on what you have drawn. Arc length is pi minus x. Yes, correct.
Yes. It can be anywhere from pi minus x to pi. Right?
C can be anywhere between.
Like if you rotate C clockwise around the circle, this is the most anti-clockwise point that it can be.
Correct.
And can go anywhere from here up till a bearing of 0 degrees.
Yeah, so which is exactly what I was asking you, whether you want me to draw this also.
Yeah.
And looks like you need this, right?
And
so let me
C has
just
to be
draw this.
within that interval.
Okay, so basically he's saying, C, this is the C left and C right. Okay.
Yeah.
So C can be anywhere in this for the circle to enclose, for the triangle to enclose the center of the circle. That's correct. Yes. Okay. Let's everyone agree with this. Okay, everyone agrees with this, right? Okay, cool. Now what? How do you find out?
Okay, now I'm not entirely sure if this method is correct, but here's what I did. Suppose the distance x. Okay, so if the distance is x, the probability of the whole the realm of possibilities for C is pi, and the possibilities which it has to be in is pi minus x. So for a chance, yeah.
No.
So for a chance for AB equals x, the chance of C being in the appropriate interval is 1 minus x over pi.
No, it's x. You're very right. It's x over 2 pi. So C can.
Can you hear me, sir?
Correct.
So you're frozen for me.
I'm frozen.
So
okay.
I'm assuming C is on the left side. We've already accounted for that.
Oh, okay, so Moksh, you're describing the probability that the triangle encloses the center or not encloses the center.
I'm describing the properties where it encloses.
Encloses. Okay. So for it to enclose, we do want C to be in this belt, don't we?
Yes, exactly.
Okay. So and this length is also x, isn't it?
Yes.
And therefore the probability that you're seeking is x upon 2 pi.
Yeah.
And not upon pi.
X over pi. X over pi. Because I've already assumed C is on the left side. We've already accounted for that.
No,
with the 1 upon 2.
Why are we assuming C is on the left side? So left alone, C can be anywhere, literally.
Yeah. But so we've already, like, this is within the 1/2 possibility of one of them being on the left side, one of them being on the right side.
Okay.
There's already within that 1/2 possibility that one of them is left side, one of them is right side.
Then you have to repeat again, right? So you have to multiply it by half otherwise, right?
I've multiplied by half already. Like I've already said at the start, there's a 50% chance they are on the same side, in which case it will not enclose.
Okay.
And within that 50% chance of it being on alternate sides, now we're examining these cases.
Okay. All right. The scaling factor by pi or 2 pi, whatever it is, we can argue. But how do you proceed from here? Depending on x, x could be small.
This is the part where I'm not sure. So we can visualize it on a graph, is what I was thinking.
Okay. Fantastic start. Anyone wants to? Okay. So from this, so till here, exactly same thing. First of all, the method I'm going to describe you need calculus, but basic calculus, not very hard.
You don't need that. Know whether it's a graph of 1 minus.
Yeah,
it's so just geometry.
Without calculus also, you can just do by proportion, but with calculus, it's very easy. So I'll just, okay. So he's describing in terms of x. I'll just describe in terms of angle, same thing. So let's say this angle is, I'll just continue on this one itself. So let's say, okay. So what have we done? We have chosen A without loss of generality to be at the bottom. And then someone comes and picks B, okay? And then I can always flip the circle such that B is on the right side of me, right? So someone picks A, let's say A is here. Then I can rotate the circle and bring it such that A is down, right? And now I am asking that person to pick B. So let's say the person picks B somewhere here. I can just flip around the circle like this, such that B falls to my right side. Again, I've not without loss of generality. So I can make A the bottom of the circle. I can make B sit on my right side, just for convenience, that's all. So without loss of generality, I can make A be the bottom and I can make B be on my right side at a particular angle theta. Now C has complete freedom to lie anywhere in the circle. Are all of you with me so far? Moksh, you're with me as well? Okay, right? So I'm just saying this is theta. He did it in terms of X, I'll just do it in terms of theta. Okay, now for this particular configuration, the probability that we are seeking is C should be in this belt, right? So the probability is theta upon 2 pi. Okay, but what is the probability that B will be at this exact theta from the vertical axis, right? So B has a flexibility to go all the way from, let's say I'm counting 0 degrees from here, from 0 to 180, because I'm forcing it to be on the right side, right? Or rather I can twist it so that it falls on the right side. So B has, okay, I'll keep everything in terms of radians, pi by 2, okay? So B has a flexibility to be anywhere from 0 to pi. Now, what is the probability? There will be a theta. For a specific theta, it will be 0. But as we saw yesterday, or rather we should ask, what is the probability that it falls between theta and theta plus d theta? So let's say this is, d theta. So this is d theta, essentially, the angle corresponding to the center. So this is theta. So that probability, do you agree, is d theta upon pi, because this entire stretch is pi, or this entire angle is pi, of which I'm seeking an angle which is d theta. So for B to be at an angle between theta and theta plus d theta, the proportion is d theta by pi. Are we all in agreement? Arab, you agree with me? Okay, and then we have to just sum it across all possible values of theta, where theta can vary all the way from 0 to pi, except that it's just not summation, but integration. So integration of theta by 2 pi into d theta by pi is the fraction probability. Therefore, as theta varies from 0 to pi. So now this becomes very easy, right? 1 upon 2 pi square, theta square by 2 from 0 to pi. So which is, so Sumer is right. So 1 by 2 pi square into pi square by 2. Pi square by 2 minus 0, which is 1 by 4 indeed. So Sumer, your intuition was right, even though you didn't fully explain it, but your intuition is right. So 1 by 4. Does it make sense, guys? Now, as Moksh was saying, we can do this graphically also. It's like you don't need calculus to find area of a triangle, right? If you have this, you don't need calculus to find this area. If you have a parabola, yes, you need, right? Integration of x square, you need. Integration of x square dx, you need. Integration of x dx, you don't need calculus. You can just literally do it by just triangle, right? That's what he was telling. For theta d theta, it's like plotting theta varies from 0 to pi, or 2 pi, 0 to pi, finding this area. You don't need calculus, right? But does this make sense, guys? Yeah. Okay, cool. And then yes, the acute angle triangle, obtuse angle triangle is again another variant of this, right? So if I have, right? So when will we have, if all three lie on one, right? If they lie on a semicircle, then this angle is 90, right? If all three lie on the same quadrant, this angle is 90. If they lie, if two of them lie on the diameter, it's a semicircle, it's a 90-degree right angle triangle. If all of them lie on the same quadrant, it becomes obtuse angle triangle. Same idea, we can figure it out, right? By 1 by 4, 3 by 4 kuch aayega, right? We can figure it out. Okay, let's move on. Which question we be doing? Homework. Which homework, guys? Can someone remind? Dipra, can you remind me? Where were we?
Yeah, I think we had the last question in homework 6 left.
Oh, the lily pads, right?
Yeah.
Okay. Okay, yeah, Dipra, did you do it? I have an answer on this one.
I had done it, but I need to find it. Just give me a minute. I don't
Okay.
remember.
Or anyone else who has it handy? What answer did you guys get?
I got 15 by 256.
15 by 256. Okay. Anyone else? Sorry, guys, I'm munching something. Any other answers? Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Oh my God. I think I've spaced it too wide. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you definitely want to reach 10. Okay, and then the danger spots are at 3 and 6. Okay, and you can jump either 1 or 2, right? So Fiona reaches pattern. Okay, so for him to skip 3, then obviously he must have taken a jump from 2 to 4. That's the only possibility. Okay, and similarly for him to skip 6, the only possibility is he must have come from 5 to 7. Okay, so let's count how many. So for him to reach 2, either he could go 0, 1, 2, or he could have done 0, 2 directly, right? Those are the only two possibilities, right? To reach 2, there's only 2 ways: 0, 1, 2 or 0, 2.
So I got 115 by 128.
15 by 128. Okay, 2 answers so far. Okay, let's see. So there are 2 ways to reach 2. Okay, so to reach here, there are 2 ways. Okay, now then obviously you have to reach 4. There's only 1 way. And then having reached 4, again to reach 5, you don't have any option at all. So you literally, you don't have any option. You have only 1 way here, 1 way here. And then you literally have to jump across 6 and reach 7. So only 1 way here. What is the probability reaches pad 10 without launching or pad 6 or pad? Okay, and then from 7 you have to reach 10, right? So from 7 you have to reach 10. So what are the possibilities? You can go 8, 9, 10, or you can go 8, 10 directly, or you can go what are the possibilities? 9, 10. Am I right? That's it, right? These are the only 2 possibilities for you to reach 10. 8, 9, 10, 8, 10, or from 7 you go and jump to 9 and then 10. So from 7 you're doing this. So there are only 3 possibilities here. What is the probability that Fiona reaches pattern without landing on? Each of them is equally likely, right? Oh, so sorry, I'm just counting the possibilities. That's not how I should do, right? I should count the probabilities, right? So for this, the probability is half into half, right? 0, 1, 2, or directly 0, 2, which is half. So half into half plus half. And then for this one, it's half cubed plus half square plus half square. Ooh, am I right? I hope I'm right. So 1 by 8 plus 1 by 4 plus 1 by 4, right? So how much is this? 1 plus 2 plus 2. 5 by 8. So 5 by 8 chance here. And then how much chance here? 1 by 4 plus 1 by 2. I'm messing up something, guys. I need some help. So 3 by 4 here. I'm not 50. I'm getting 15 by 32, which is not even in the options.
So you messed up in the 3 and 6 terms. Your 10 ka thing is right, but
oh no, I'm missing the probability. I'm forcing. I'm not multiplying by these probabilities at all. We are forcing that it has to go from 2
yeah,
to
so
4.
your 5 by 8 is right, but I didn't get 3 by 4 for that.
So for us to reach 2, it is 3 by 4, no? 0, 1, 2, which is half into half, or 0, 2. Just 1 second. Sorry, that was my mom, so I had to pick it up. Okay, so either 0, 1, 2, which is half into half, or directly 0 to 2, which is half, right?
When you took the jumps, you first it as 1 instead of half over there. Like the probability.
Sorry, say that again.
Wherever you took it as like only 1 way, like 1 jump, you wrote it as 1 instead of half. Like
Correct. Yes, I realized that mistake. I was just changing it. So I'm okay on this 3 by 4 also. The probability of reaching 2 is 3 by 4, right?
No.
Oh, I thought Ritisha did not agree with that one. So what is forget everything else. What is the probability of you reaching 2 you could go to 2 by doing 0, 1,
You have
2.
to calculate probability of reaching 4, right? Not 2.
To reach 4, you have to first of all reach 2.
Yeah, so you can do, so it goes from 0 to 1, 1 to 2, and 2 to 4. That's 1 by 8. Or it goes from 0 to 1, 1 to 2, and then 2 to 4. So that's 1 by 8 plus 1 by 4.
Yeah, see, that's what I'm not including the 2 to 4 jump. So I'm saying before even you reach 4, I have to halt at 2 for sure. Only
Okay.
then I can take a jump. So I'm just saying 0, 0, 1, 2 or 0, 2. Okay, so these two add up to 3/4. Now I am at the point 2. Okay. And now from here, I have to definitely jump. So which is your half multiplication, which gives 3 by 8. So now I've reached the point 4. Okay. And now further half to reach 0.5, a further half to reach 0.7, and then the further 5 by 8, which is the last step. So which is indeed 15 by something. 15 by what? 15 by 256. Yeah, 15 by 256 indeed. So whoever got 15 by 128, do you agree that was wrong? Or I have to look at the answers here. I don't have it offhand, but it seems like 15 by 256 is right. Whoever got 15 by 128, do you agree? If I found your mistake?
So that was me only, but I couldn't read my handwriting, so it was 256 only.
Okay, all right, good. Okay, next paper, which is this paper 6, right? Paper 7. Okay, binary operation, this one. This is, yeah, Anika, what did you get on this one?
I got 109A.
109. Okay. I think this is fairly straightforward, right? Seeing A, whatever, A operator A is 1, the first guess would be that you'll try division. And then division seems to satisfy this also, right? A divided by B by C is same as A divided B times C. And therefore you go with that one, right? But is there a way to prove, I mean, for the purpose of AMC, this is enough, but can we prove that the operator has to be division? I mean, this is not needed, I'm just asking you. Division.
Noticed at first that it satisfied the properties of division, so I just did it like with the information that was given. I made a few observations and then
Yeah, as far as AMC is concerned, that's the quickest way to do it, right? So we observe division works, and so we'll just move on with it. But I'm just asking, right, for more formally, how do we prove that it has to be division only and nothing else? If you guys thought about this one. Again, not for the purpose of AMC, I'm just for the fun part of it. Okay, so in general, like this happens often, right, in number theory and stuff, right? One standard trick is try like symmetry and try putting one number to be one extreme case and all that, right? So suppose I put all the 3 numbers to be same. So A operator, okay, this is too much for me to write. I'll just call it star or something, right? I'll just call it star. This is easy for me to write. So A operator, B operator, C, right? So I'll just let A equal to B equal to C. Okay. So if all 3 are same, then the property is telling me, he is telling me that A star A is A star A times 1. Okay. Times A, sorry, times C, and C is also. Okay. But then A star A is already given to be 1, right? A star A is given to be 1. So which means A star 1 is 1 times A. Correct? A star A is 1 times A, or A star A is just A. This is just multiplication, right? So A star A is A. So that's one information, one inference we have. Okay, and now let's say I keep A same as B or B same as C, one of them. I can just try, right? So because I have B star C, I have A star B here. Let me try B equal to C. Okay, B equal to C. So I have A star B star B equal to A star B times B. Times B, right? Okay, times B. Now, does this tell me any extra information? So B star B, I know is 1. B star B, I know is 1. So this is telling, because B star B is given to be 1, right? Yeah. A star 1 is A star B times B. So this is not telling me much. Okay, this is not telling me much. Now,
Actually,
is it?
I already know that A star 1 is A, so A star B is A by B.
Where do I know? Correct, exactly. Yeah, that we go. Yeah, A star 1, in fact, it was right here, right? A star 1 is A, therefore A equal to A star B times B. And therefore we can just, exactly, we can bring the B to the side and say A by B equal to A star B. Yeah, so that's how you derive like patterns and all this, right? Again, this is more for people preparing for RMO, INMO and all that. But for AMC, this is good enough. Okay. Next one. LCM triplets, this one. Arnav, did you have time to try this yesterday? I know yesterday you didn't have time to try many of the problems, but did you? After that? Arnav, are you able to hear me?
Yeah, no, I didn't. I had guests over because Diwali, so I didn't.
Okay. What about Rahel, you?
No silent trial.
Okay, who tried this? Soham?
So I tried it, but I couldn't solve it.
Okay. Yeah. Okay, Ritisha, your hand is up, but I want to give someone else. Arav, did you?
No, I didn't have that.
Okay. Yeah, Ritisha, tell me, what did you do on this? Or what did you get rather? Let's
I
first.
got 15.
15. Okay. Any other answers?
I got 15 as well.
You got 15 as well. Okay, Dipra, can you share? What did you do, Dipra?
Yeah, so the first thing that I did was I factorized like 72, 600 and 900. So
Okay.
I got like, so 72, 2 raised to 3 into 3 raised to 2.
Okay.
Then 600, so 2 raised to 3 into 5 raised to 2.
2 raised to 3. What is the 600? Sorry, 2 raised to 3 into?
5 raised to 2 into 3.
Okay, I'll put 3 in the middle. So 3 into 5 raised to 2. 24 into 25. Yes. So this is for X and Z. Okay.
And then for 900, 2 raised to 2 into 3 raised to 2 into 5 raised to 2.
Yeah, that's 30 square. Therefore, 235 whole square. So 235 whole square. Okay, all right.
So then just for me to understand better, I kind of made like a triangle thing and wrote like X, Y, Z in each of the things. So I just had like with
like X, Y, Z like this.
Yeah.
Okay. Okay.
And then like I just wrote like 2 raised to 3, 3 raised to 2, like between X and Y, like each of the just
wonderful. Yeah, wonderful. I really like this suggestion. So 2 raised to 3, 3 raised to 2, and then here it's 2 raised to 3, 3 raised to 1, 5 raised to 2. Here it's 2, 2, and 2. Okay.
Yeah. So if you take each of like X, Y, and Z as like 2 raised to some power, 3 raised to etc. You know that X has to have 2 raised to 3 because like the other two don't.
Exactly. Yes. Perfect. Yes. Okay. Yeah. So basically she's saying why. So let's take each prime number separately, right? So prime numbers that way are very easy to deal with. They are all independent, right? So first let's conquer 2. So we are saying between Y and Z, the maximum power of 2 is only 2 power 2, right? So if I have power of 2, the max is 2 here, right? Max is 2. So max is 2 here. Okay, sorry, my handwriting is very clumsy. Okay, but then we between X and Y, we have 2 power 3. And between X and Z also we have 2 power 3. So clearly, okay, first let's deal with power of 2. So power of 2, X must be 3. Okay. And then power of 2 between Y and Z. So between Y and Z, I need 1, 2, but the other can be anything. So it can be 2 with 0, 1, and 2. Or it can be 2 here and 0, 1, and 2. So there are 6 cases, but then one of them is a repeat, right? 2, 2 is a repeat. So 3 and 3, 6 cases, but 2, 2 is a repeat. So there are 5 cases where it will satisfy YZ with a max of 2. And X is frozen at 3. Okay. The power of 2 is 3. Okay. And similarly, exactly. So Very good, Dipra, well explained. And similarly, you will proceed with 3, right? Same thing. So power of 3 is, what is it? It's 3 power 3 power 2 here, 3 power 2 here, and 3 power 1 here, which means X and Z are constrained by having a maximum of 1, which means Y must be the leader with a 3 power 2 in it. So Y must have a 3 power 2. Okay. And then X and Z have max of 1, which means it can be 1, 0 or 0, 1 or 1, 1. So there are 3 cases here. So 3 cases here, and then 2 cases. So how many? 6 cases here, sorry. So, sorry, 5 cases here, 5 cases here, and 3 cases here. So now similarly with Z also, sorry, with 5 also, but let's see, 5 times 3 is 15. So first of all, again, from AMC perspective, I don't see any other multiple of 15. This is the only multiple of 15. So everything else must be, but anyway, just for completeness, let's do. So, but same idea. So the power of 5 is 5 power 0 here, right? So here it's between X and Y, it's 5 power 0. And between X and Z is 5 power 2. And between Y and Z, it's 5 power 2 as well. So clearly X and Y are power 0 and 0, and the 2 has to come from Z, right? So there's only one case here. Therefore, 5 into 3 into 1, 15 cases. Yeah, well done. Anika, your hand was up. You also did something very similar.
No, my hand was not up.
Oh, okay. But did you do it as well?
I actually didn't. I wasn't able to do it. I was trying to think of a different method. I didn't get it.
Okay. But does it make sense to everyone, guys? Arab, makes sense to you now?
Yeah.
Okay. Rahil, Soham, turn on the cameras, please. Next one. Yeah, next one was a really good question. Okay. Anyone on this one? There is a smallest positive integer, positive real number A.
I got 9.
I also got 9.
Yeah. Okay. 9. Any other answers? Anika, okay, can you take me through your 9?
Yeah, so first I used Vieta's formula to find like A and B in terms of the roots. So then
okay, so let's write. So let's say alpha, beta, and gamma are the roots. So A is alpha plus beta plus gamma, sum of roots.
yeah,
B is A alpha beta plus beta gamma plus gamma alpha. And then A is again alpha beta gamma.
Yeah.
Okay.
Then I thought about like using the AMGM inequality because I saw alpha plus beta plus gamma and alpha beta gamma. And then
Excellent.
I got that wait, I don't have my
Yeah, that's fine. Yes, exactly. So whenever there's an inequality, so this is a very, I don't think I covered this, but maybe I did. The arithmetic mean is always greater than or equal to geometric mean with all positive numbers, right? So we know this with A plus B by 2 is greater than or equal to root of AB, right? We know this because if I square both, so I have A square plus 2AB plus B square. And if I bring the 2 to this side, is greater than or equal to 4AB, right? That's because A minus B whole square is greater than or equal to 0. You can reverse the steps, and therefore you can observe that A plus B by 2 is greater than or equal to root AB. But the same thing can be extended for n numbers. So if I have A plus B plus C plus D, so on, let's say n numbers, that's the arithmetic mean. This arithmetic mean will be greater than or equal to the geometric mean. The geometric mean is A, B, C, D. Okay, then let's say there are n numbers. The nth root of them is the geometric mean, right? Just like arithmetic mean is a number which when you multiply by n, you'll get the sum. Geometric mean is such a number, when you raise it to the power n, you'll get that product. Okay, and I don't remember the formal proof for this, but through triangle inequality, you can do extending the triangle inequality. This is the standard result. Arithmetic mean is greater than or equal to geometric mean. That's one. More importantly, the equality happens when the numbers are same. So for example, if the two numbers A and B were both A and A, then the arithmetic mean is A plus A by 2. The geometric mean is square root of A square, which is A. Again, all positive numbers. Okay, and similarly, even for n numbers, the equality holds good only when all the numbers are same. Okay, so that's what she's doing in this case. So she's saying She's observing it because the same alpha plus beta plus gamma is here and alpha beta gamma is here. So she's saying alpha plus beta plus gamma by 3 must be greater than or equal to alpha beta gamma power 1 by 3. Okay, that's a very important step. Okay, therefore, in terms of sum of roots, we know that this is A. Therefore, A by 3 is greater than or equal to A power 1 by 3. Okay, and since everything is positive, right? So we don't have to worry about signage and all, right? So A power 2 by 3 is greater than or equal to 3, which means A is greater than or equal to 3 power 3 by 2. So which is 3 root 3. So A is greater than or equal to 3 root 3. And then he says, what is the smallest possible A? So the smallest possible A is 3 root 3 itself. So if A is 3 root 3, and that occurs when we know that alpha, beta, and gamma, all three must be identical. Only then the equality occurs. Okay. And when that occurs, what happens? Your B is your sum product. So which means alpha, beta, gamma are each 1/3 of 3 root 3. Or which is root 3, or another way, cube root of 3 root 3, which is also root 3, right? It must tie out both ways. Either 3 root 3 divided by 3 or 3 root 3 power 1 by 3. Both should be same. Okay, that's how we arrived at it in the first place. So root 3, and therefore B is root 3 into root 3, 3 times. So 3 plus 3 plus 3, which is 9. Yeah, very good question. Yes, well answered, right? What is value for B? Okay, yeah, makes sense, all of you. So yeah, so some of the later questions, I can, there is some definitely in the 20 plus 22 plus range of questions. You'll have to have some innovative thing like this. At least until problems 20, there's a straightforward way of doing a problem. Now beyond 22 and all that, you have to pull out a rabbit from your hat, right? One of these. All of us know that rabbit. We have to just pull it out at the right time. So that's the only thing. Okay, that was question 3. Let's skip question 4. It's a bit of a tedious question. Let's come back later. Question 5, complex numbers. This one should be fairly easy, right? Rahul, did you have time for this, or you didn't have time for any of these questions?
Yes, I got this.
This one. Okay, what did you get, Rahul?
Yeah, 12.
12. Okay, any other? Get the same answer? 12?
Same answer.
I got
Same
12.
answer? 12 as well. Okay, so z power 6 is a real number. Z power 24 is 1. So which means each of those roots is equally spaced around origin, right? Around origin. So the first root being here, right? And each of these will be at whatever 360 divided by 15. 360 divided by 15. Sorry, 360 divided by 24, I'm sorry, at 15 degree angles. So 15 degree, 30 degree, 45 degree, and so on, right? And then he's asking how many of them z power 6 is a real number. Okay, so okay, so 15, so times 6, if we do 15 degrees, right? Okay, yeah. So 15 times 6 will end up at 90. That won't do. 30 times 6 will land up at 180, which is a real number, right? So 30 will land up. 45 will not land up, right? 45 will land up at 60 will land up. So 30 and 60 will land up. And similarly, a couple of them in each of these quadrants, right? So 30 and 60, when you multiply by 6, it's back to the x-axis. And then if you have on the x-axis itself, the 0 and 180, that also will work. What about these? 90 times 6 is 540. And 270, that also times 6 will also be landing on the. So am I counting it wrong? Yeah, 2 times 4 is 8. 8 plus 4 is 12. Yeah. Yeah, just counting, guys. Okay, multiple ways to count the same thing. All of you okay on this one, right? Siddharth understood this fully? You got the same answer, I hope. Question 6. Siddharth, were you able to do question 6?
So I went through them, but I actually didn't solve them.
Okay.
6 was a bit doubtful though. I didn't get a method also for this.
Okay, Sumer, how about you? Did you try 6?
No, sir. I didn't finish the sheet.
Okay. Other than the usual responders, I want some other. Moksha, did you try this?
Yeah, I got it.
Okay. What did you get and what did you get first of all?
I got 1239, option D.
Okay. All right. Others who solved same answer?
Yes, same answer.
Yes.
Yes, sir.
Okay. Okay, good. Soham, you want to take this? What did you do? Oh, so Rahil, your hand was up. Yeah, go ahead.
So I got E.
Okay, you got 1265. Okay, a different answer. Okay. Yeah, Soham, what did you do to get 1239?
So I found the difference between 1274 and 1239, which was 35.
Mhm.
And so if so n must end with 9.
But then why did you choose this in the first place? 1274. I mean, as we see the problem, or are you doing this difference with every number, with 1, with 3, with 12?
I started with like the n ending with 9, and then I saw like what all differences, how much change could be possible in the sum of its digits. I did it with every option. Yeah, I tried.
Okay, all right. So, and then with every option, what was your thought process? You do the difference and then?
Then if it had to be like it had to be 9 plus, I mean, it had to be 1 plus all the 9s which were changed to zeros.
Okay.
So like 35 is 9 into 4 minus 1.
So basically you're saying all the options given are less than 1274, which means you're expecting a bunch of 9s, right,
Yeah.
at the end. And then when you add 1, you're going to get a bunch of zeros. And
Mhm.
therefore the total S will come, S of n plus 1 will be smaller than S, right? S of n plus 1 will result in a smaller number than S of n.
Yeah.
Okay. Okay. Continue, please.
No, so then I tried the options and the other ones didn't match.
I'm not clear. What didn't match? You need to be clear on what matched and what did not match.
So I eliminated option E because
On
there's a
what basis?
because if I add 1 to a 9, then that becomes 0, and then there's a 1 added to the next value, like placeholder. So the difference would be 8.
Mhm.
And
So
eliminate.
basically you're saying if this ends in 9, okay? So let's say this digit is something else like 7 or something, right? So when you add 1, I get 0, okay? And then I borrow 1, I get 8, okay? So 7 plus 9 was 16, whereas 8 plus 0 is only 8, okay? And this difference is 8. So I expect the S of n plus 1 should be 8 less, which is 1266, whereas it's 9 less. And then probably try, what if it's something like 599? It's 599, then you get a 0 here, you get a 0 here, you get 1 here. So this adds up to 6, whereas this adds up to 23. This difference becomes 18.
Yeah.
Right, which is too much. So which is why 1265 will not work. Okay. Continue.
So difference is 18. I did a similar thing for A, B, and C.
Okay.
So can I explain? I use the same method.
Yeah, go ahead, Ritisha.
So
Yeah.
it is essentially the difference essentially has to be a factor of 9 minus 1. So if you subtract all the answers, so 1274 minus 1239 is how much? 35, right? And that's 36 minus 1. So because 9 into, so 4 times 9 comes and then you add 1, so 36 minus 1.
Okay, so basically you're saying, so basically what she's, okay, why does it have to be a difference of multiple of 9 minus 1?
Because you have these 9s, you don't know how many. So you keep on subtracting 9, but at the end that one carry forward gets there. So your 9 into something, 9n minus 1.
Yeah, I made a mistake here. It's 17. Yes. So it's 9n minus 1. Correct, right? So you have a bunch of 9s and then there's one extra one at the end. So which compensates. Therefore, the difference is 9n minus 1, or rather I'll just say 9k minus 1, right? There's n already in the picture. So the difference is 9k minus 1. So Soham, you're mostly on the right track. You just had to complete it. Yes, you have to see the difference. Another way to look at it is, okay, so whenever I have sum of digits, I think of divisibility by 3 or divisibility by 9, right? So, so if I have a number s of n plus 1, okay, and if I look at the number, or rather any number, n itself, right? N and the sum of digits of n, right? Both have the same parity. Both are the same modulo 9, right? So both will be, let's say, a modulo 9, right? That's how you do the divisibility test, right? How do you find if n is divisible by 9? You just do sum of digits, right? And if the sum of digits is divisible by 9, it's divisible. If it leaves a remainder of 5, that means n also leaves a remainder of 5, right? Sum of digits of number is same modulo 9 as the number itself. So same thing happens with n plus 1. So n plus 1 and s of n plus 1, right, now is also the same, p modulo 9, let's say, right? But n and n plus 1 are apart by 1, right? Therefore, this is effectively 1 extra, right? A plus 1 modulo 9. Are you guys understanding this? N and n plus 1 are differing by 1, or rather n plus 1 is 1 more. Therefore, n plus 1 will leave a plus 1 modulo 9. Of course, if it goes beyond 9, then you set it back, but a plus 1 modulo 9, which means the difference, if I do the difference between these two, right? So n plus 1 minus n, right, is 1 modulo 9. This is, you don't need too much, right? So difference between two numbers is obviously 1, and that's 1 modulo 9. But the difference between s of n plus 1 and s of n is also 1 modulo 9, right? Which is exactly what she was saying. But then I'm getting s of n plus 1 modulo 9. Where are you getting minus 1 modulo 9? Oh, yeah, plus 1 modulo 9. Yeah. So if s of n is 1274. So I'm saying 1274 plus 9k plus 1, right? Of course, k can be negative as well, right? So it's either, for example, the next number is 1284. The next number after that is 1293, and so on. But all of these numbers are going in the front. So going back, it's 1274 with k as being negative number, right? So minus 9 plus 1, or minus 18 plus 1, minus 36, minus 27 plus 1, and so on. So by that logic, it should be minus 35 or minus 20, how much? 26, and so on, right? So, and this works out to be, so we can just see the difference between 1274 on each of them, and just check if 1273 is 1 modulo 9 or not, right? And then this difference is or minus 1 modulo 9. Oh, sorry.
So if you see for 1274, it's 4 mod 9, and then if you check all the answers, the only one that is 5 mod 9 is D. Can't you just do it that way?
Which one? Say that again.
For 1274, it's sorry, give me a sec. Yeah, it's 4 mod 9, right? Wait.
Yeah, 1274 is 4 mod 9.
And D is 6 mod 9.
Yeah, sorry, my bad. Yeah, that's what's confused.
Okay, yeah, correct.
D is the only one that's 6 mod 9.
Exactly, yes. We don't have to do all this nonsense that I did. Yes.
It's only applicable for 9 if it's sum of digits.
Yeah, sum of digits applicable for 3 also, right?
Yeah, but he is using 4 and 5, right?
Who's using 4 and 5?
Someone said he used 4 and 5, right?
No, that was the remainder modulo 9.
Yeah, that was just for this question.
Oh, okay.
So he's saying 1274 is 5 modulo 9. After dividing by 9, he's figured out the remainder is 5. And therefore, s of n plus 1 must be 6 modulo 9. And he's just testing which of these numbers is 6 modulo 9. 1 is not 6 modulo 9. 3 is not 6 modulo 9. 1239 is 6 modulo 9, apparently. I didn't check, but 1233, yeah, 1233 is perfectly divisible. Therefore, it's 6 modulo 9. Yes, that's easier rather than all of this 9k stuff. But idea is same. Yes. Okay, good. Next one. How many ordered pairs? Okay, Sumer, we're able to do this one.
I told you I wasn't able to complete this.
Oh, okay. Anyone? Rahil,
I got 398.
398. Okay. Rahil, what did you get?
I got 597.
Okay. And Moksh, your hand was also up.
I got 199.
I
199.
got 597.
97, yeah.
Okay. All right. So 3 different answers. So let's discuss how many ordered pairs A and B. A is positive real number. Pay attention to everything, guys. And B is an integer between 2 and 100 inclusive. So every word is important, guys. Okay. Because that can drastically change the answers. Okay. So log of A to the base B. And here also there's log. So this is log A to the base B whole power 2017. And this is 2017 times log A to the base B. Okay, so we can take log A to the base B as some C, right? So C power 2017 is 2017 times C. Okay, A is a positive real number, B is an integer. Okay, so this is C power 2017 minus 2017C equal to 0. Never cancel, guys. Never. It's very tempting to cancel C. Don't do that because you lose out on a solution. So always do this and then cancel. So 2016 minus 1 is 0. Okay. So one sec. Let me remind again. So A is what? A is positive real number. A is greater than 0. A is an element of real number. I like to write it like this. And then B is an integer between 2 and 200. B is an integer, right? B is an integer between 2 and 200. Okay, good. Okay, now C, therefore, C can be any real number, right? C can be any real number. C can be any real number. So what are the solutions here? So C is 0 is one solution. And clearly in the complex plane, we'll have 2016 roots for this, but we are in the real numbers. Therefore, only 2 answers, right? So this is 2017. So there are only 2 answers. Because 2016 happens to be an even number, it's plus or minus the root of this. The 20. Okay, I'll just write it like this. 2016 root of this.
So there should be 3, right? Because there's 0 and then plus minus and 0.
Yeah,
Yeah.
I put 0 here, and then I put the plus here, and then I put the minus here. So 3 values for C.
So total 3, yeah.
Yeah, so C1, C2, and C3. So there are 3 roots for each B, right? And B itself can vary. So if B equal to 2, and then let's say C1 equal to 0, that will give me 1A. So what is A B? B power 2 power 0, which is 1. Okay, A will obviously repeat. When B is 0, C1 is 0, A will be 3 power 0, which is 1. But these two are different. Even though A repeats, we are looking at the ordered pairs A comma B. So even if one of them changes, it's a different ordered pair, right? So he's looking for number of ordered pairs A comma B. Okay, and similarly, B is 37, and C, say C2 is 2017 power 1 by 2016. You'll get some nasty A, some number, right? And then similarly, some other number, right? So essentially, it's the product of for C1, C2, C3 for each B. And how many numbers are there? 200 minus 2 plus 1, both inclusive, right? Therefore, it's 199 numbers. Yeah, so 3 into 199, which is 597 indeed. So whoever got 398 probably multiplied by 2 instead of 3. Whoever got 199 multiplied by 1, right? So 3 solutions. That's the differentiator, right? C1, C2, C3. Okay. Just one second. Let me switch on the light here. Okay. Okay, next one. This one. Certain real numbers. Yeah, whenever this polynomial is like this, it's all going to be Vieta's formula for sure, right? Sum of roots, product of roots, all of this put together.
So it actually isn't in this case.
It's not in this case.
No.
Okay. Okay. For certain real numbers A, B, C, have three distinct real roots. G of x is also a root of the polynomial. Okay. What is f of 1? Okay. Moksh, what did you do? And what did you get rather?
I got C, I believe. Let me just check.
Okay.
This is question. Yeah, I got C.
Okay. And what did you do, please?
Okay, so the first thing I noticed was that each root of g of x is a root of the polynomial f of x.
Yeah.
And the root basically means x minus some linear thing is the root.
Yeah.
So that
So
means if every root of suppose g has roots alpha, beta, gamma,
okay.
x minus alpha, x minus beta, x minus gamma.
Okay, and then further multiplied by x minus
exactly,
delta would be f of x.
So f of x, we have to find that x minus delta. I just divided f of x by g of x, and I got no, sorry, I worked in reverse, like g of x into what linear polynomial gives f of x.
Mhm.
And so first the coefficient g of x into ax plus b equals f. That's right.
Yeah, a is just 1 because x cubed here and x
Yeah,
power 4 here.
exactly.
So we
X plus-
literally have to find delta. Okay, so let's do this. So x cubed plus ax square plus x plus 10 times x minus, I'll just call it d, right? D is anyway, or d or d for delta. Okay, I'll just say d. Okay, d is the root, right? Equal to f of x, which is again, right, x power 4. We know that the linear, I don't need ax plus
Yeah,
a is first
linear
of all
thing,
taken here.
because
First of all,
cubic
I don't
to
want to use.
quartic.
Yeah, x cube plus bx square plus 100x plus c. Okay, now you are just comparing coefficients and getting right. Probably x cube times x is x power 4. Now you are comparing. So let's compare the x. Sorry, I don't want to take the thunder from you. You're comparing the coefficients for x cubed and equating both same. Is that right?
Yes, exactly.
Okay.
And
Yeah.
you find out d must be equals to 1 minus a.
Excellent. Yes, same. This is in other words, this is also sum of roots, product of roots only. But yes, this is fundamentally right. Okay, makes sense, right? So he's comparing x power 4 coefficients is matching. X cube coefficient on the right hand side, we have the x cube coefficient is 1. Okay, on the left hand side, the x cube coefficient is what? This x cubed multiplying the minus d, and this x square multiplying this x. So minus d plus a is 1. Okay, compare the x square coefficients. We have b on this side, and on the left hand side, the x square is got by this x square multiplying the minus d. So minus ad. Okay, again, please watch out if I do some silly mistake, please. And then plus x multiplying the x, which is 1. Now comparing the x coefficient, it's 100 here. And then this 10 multiplying this 1, so which is 10. And then this x multiplying this minus d. Yeah, correct. Minus d. Okay, and then lastly, the constant functions, constant c is got by minus 10 t. Okay, so 4 variables, 4 equations, we should be able to do very easily. So in fact, and I wouldn't say very easily, in this case, it's laid out nicely, right? We can separate it out. So d is immediately 110, is it? 110?
D minus 1.
No,
yeah.
From this equation, d is 100. No, not 110.
90.
Minus 90. Minus 90. Minus 90. So d is minus 90. I can put that in which one? I can put that here in the first one, and I can infer a is minus 89. A is minus 89 from here by muting this. Now I know my a. What do I need, by the way? I need f of 1. So I need f of 1 is what? 1 plus 1 plus b plus 100 plus c. So I need both b and c. So it's effectively b plus c plus 102. Okay, b plus c plus 102. That's what I need.
So you can use the first equation, g of x into 1 minus d.
Ah, nice. Yes, understood. So I already know a, you mean? Yeah, that's what you mean, right? So essentially you need f of 1. So she's saying f of 1 is g of 1 times 1 minus d. And g of 1 is 1 plus a plus 1 plus 10. Okay, so which is 12 plus a times 1 minus d. So I found my a and d. She's saying, why waste time? Excellent, I love this. So 12 plus a is minus 77. So minus 77, and then 1 minus d is 91. So 77 times 91, hopefully that will be the number ending in 7, unless there's some other mistake, right? 77, can someone confirm 77 times 91 would be this?
Yeah, you get C.
You get C? Okay, nice. Okay, but yes, sum of fruits, product of fruits will essentially give the same thing. In fact, what is sum of fruits, product of fruits? It's coming from this only, right? When I have x minus alpha times x minus beta times x minus gamma, right? Right? And when you write it as x cubed, or rather ax cubed plus bx square plus cx plus d, right? If I have a here, if I first of all cancel the a, then all of them become this. Now, what is, if I'm equating the coefficient of x square, what am I doing really? This x multiplies this x and then multiplies this minus gamma. So minus gamma, minus alpha, minus beta, that is your b by a. In other words, sum of fruits is minus b by a. So when you're equating the coefficients, it's same as sum of fruits, product of fruits. So Moksh, what you're doing is also the same thing, Vieta's formula only. Are you in agreement, Moksh? Okay, he has disappeared somewhere. Okay, that's fine. All right, let's do one more and we'll finish for today, guys. So let's do the last one, maybe. Yeah, let's do the last one. I'll skip a few questions. Let's do this. Which of the following? Okay, x square plus y square equal to a square and y equal to x square minus a. Intersect in exactly 3 points. Who tried this? Rahil, did you? Siddharth? No, anyone? Dipra?
No, sir, I haven't tried this.
I got E.
Even I got E.
A greater than half. Okay. All right. So let's see. So what is this? X square plus y square equal to a square is a circle. So this is a circle. So circle with a as the radius. And okay, so this is the circle. And then y equal to x square minus a is a parabola. So this is a comma 0. This is minus a. This is 0 comma minus a, right? And 0 comma a. So x square minus a is a parabola, and that also passes through 0 comma minus a. And then the roots are root a and minus root a. So let's assume if root a is inside this, right? So in the way I have drawn, root a is smaller than a. Okay. So I'm just drawing a general diagram for now. Okay.
Right, this is algebraic.
Yeah, algebraically would be easy. Yeah, correct. So exactly at 3 points, right? I think algebraically would be easy. So y equal to x square minus a. So let's do that. X square plus x square minus a the whole square equal to a square, right? So this is x power 4. This is x power 4 minus 2a x square and then plus another x square plus a square equal to a square, right? So we have x power 4 equal to 2a minus 1 into x square. So this equation must have only 3 roots, right? Or exactly 3 roots. So actually has 4 roots. What you mean is 3 distinct roots. So x equal to 0 is clearly 1 root. X power 4 equal to x square. That's the repeated root. Which means I have x square. Okay, I'll write it as this way. X square minus 2a minus 1. So should be equal to 0. Must have 3 distinct roots, which means x equal to 0 is 1 root. So this guy must have 2 distinct roots, which means 2a minus 1 should be what? 2a minus 1 must be 2a minus 1 must be a positive quantity, right? Yeah, 2a minus 1 must be a positive quantity. X square minus positive quantity equal to 0. Yeah, correct. Which means a is greater than half. Yeah. Sorry, I don't know why I was struggling at the end. Yeah, same thing, right? Whoever did algebraically, was it you, Ritisha?
Yeah, sir.
Yeah. So yeah, actually have 4 roots, but at 0, obviously you'll have a repeated root, the other 2 roots. So what do you mean by a is greater than half? So a is greater than half. So if a is greater than 1, no problem at all. Just diagrammatically itself, a will be to the right of root a, right? If a is bigger than 1, the square root of a will be smaller, right? But if a is less than 1, root a will be larger. So if it could fall like this, right? So the parabola could be like this. I mean, just if you're interested, right? So A will still be at the edge point of the circle, but root A could be further away, but there could be an intersection here and here. So as long as it's not too flat a parabola, it can still have 3 intersection points. But if it goes beyond a certain point, as in less than even half, then the parabola becomes very, very flat, in which case it does not have any intersection points at all, right? So yes, algebraically is good, but also geometrically also you should visualize, Ritisha. Okay, you should be able to, not just Ritisha, everyone, right? Whatever you do, it's always good to check both ways, algebraically and geometrically. You should get the same feel. Okay, all right, let's stop here. Wonderful. I really enjoyed teaching this batch of AMC12. Very, very engaging, participating, and multiple different viewpoints. So yes, keep up the good work, and hopefully we'll meet sometime in the future for something else. Okay, all the best. Let me know how it goes tomorrow. If it goes great, that's nice. If it does not go well, everyone has an off day, so don't sulk or anything. The effort is what counts, and the preparation. All of you I wouldn't say all of you put in a lot of hard work. Many of you I can see put in a lot of hard work, but others I know you had so many other constraints, so managing this is also tough. Okay, but hopefully it was useful. But we'll meet sometime in the future. Okay, chalo, bye. See you guys. All the best.
Thank you, sir.
Thank you,
Bye,
sir.
sir. Thank you, sir.
Thank you, sir. Thank you, sir.